In question number 20, they ask us to find the coordinates of W that is on the circle, and they tell us that angle HWS, so this is 60 degrees, and this should be 90, which would make this central angle 30 degrees. And hopefully you remember some special things about 30, 60, 90 triangles. The first thing to notice, though, is that on the actual circle, they tell us that this coordinate is 6 away, which would mean that this should also be 6 away. In fact, it's -6, 0. So the radius anywhere you go is going to be 6, which also means that this from S to W is also 6. And that's because the radius is 6. Well, if you remember from special right triangles, opposite the 30 is half of that amount. So this should be a 3. And HS should be a -3 square root of 3. And the reason why it's negative is because we're going to the left. Just like this was -6, this is a -3 square root of 3. So they want the coordinates of point W. Well, we would have to go to the left first, which is -3 square root of 3, and then we would have to go up. So those are the coordinates. In question number 21, they want to know if this is a circle or a parabola, and I noticed that there's only one variable squared, only the x is squared. If that's the case, it's a parabola. So in order to be a circle, both the x and the y have to be squared. But in our case, only x is squared. They want us to rewrite it in vertex or standard form. So in order to do that, I actually have to bring the y's to the other side. So on the other side of the equation, I actually have a positive 8y, because you would have to add it, plus 12. I'm now going to complete the square. So you take half of this number, which is 4. Half of 4 is 2, sorry, and 2 squared is 4. So over here you put a 4, and on the right-hand side we put a 4. Hopefully you realize now by completing the square that this becomes x minus 2 squared. On the right-hand side I have 8y plus 16. Now the right-hand side is almost done. The only thing is I have to factor out the greatest common factor on the right. So I'm going to write it below here. It turns out that I can take an 8 out of both terms, and when you factor or divide it out, you get a y plus 2. Remember, 8 times 2 is 16 there. So that's in the correct form now, and I can now state what the vertex is. And the vertex is going to be at a positive 2, because this is a negative, and then the y is at a -2. And since the formula is always 4p, if 4p is equal to 8, p has to be 2. In question number 22, they want to know if the point 615 is actually on the circle. And similar to the one we did earlier, what I'm going to do is I'm just going to plug in the 6 for the x value. I'm going to plug in 15 for the y value, and then I'm going to check to see if the left-hand side, when I simplify, is equal to 225. So when I substituted everything in, I got 8 squared, because 6 plus 2 is 8, plus 11 squared. When you square those, you get 64 plus 121. When you add those together, you get 185, which does not equal 225. So that means no, it is not on the circle. If you were to graph the original circle and check to see if 615 is on it, you could probably tell that it does not lie on the circle. In question number 23, they want us to write the equation of a circle. They give us the center is -5, 3 and a radius of 16. And if you look at the second part, it's the same thing, except this time the diameter is 16. So we have to be really careful. In the first part, it's going to be x plus 5 squared, because it's always the opposite, plus y plus 3 squared. and then you always square the radius, which in our case would be 256 because that's 16 squared. In the second equation, it's also x plus 5 squared plus y plus 3 squared. But the only problem is they told us the diameter, so you don't want to square the diameter. If the diameter is 16, the radius is really 8, and 8 squared would be 64. So notice that they're different equations, and that's because one circle has a bigger radius than the other one. In number 24, they're asking us to find the area of the triangle WHS, which is given below. So the first thing is there's a right angle here, HWS. So that's this angle is 60 degrees, which means the central angle here has to be 30. And they want us to find the area. So the first thing that I notice is on our circle right here, they put that at 0, -8. So that means the radius is 8, which means this is also 8. So hopefully you remember from your special right triangles that if it's 30, 60, 90, opposite the 30 is a 4. Opposite the 60 is 4 square root of 3, but it's technically negative because you're going to the left. So what they really want though is the area. Area is just the amount of space it takes up. So all I'm going to do is base times height divided by 2. The base is technically just 4 square root of 3 if you look at the length. The height is 4, and then we have to divide by 2. So I'm going to divide by 2. 4 times 4 is 16, so I get 16 times the square root of 3 over 2, and 16 divided by 2 is 8 square root of 3, so that's the area of that triangle. In question number 25, it says the coordinates of ABC are given, so I drew them on here without doing it on graph paper. They tell us WH is the mid-segment, so hopefully you remember this from earlier in the year. That really means that these parts are equal, these parts are equal, so W and H are in the middle. They want to know what the coordinates of W would be. Well, if it's in the middle, then we just use the midpoint formula. So you add the x's and divide by 2, add the y's and divide by 2. So in our case, that would be 5 plus 1, and then you would add 12 plus a -2, and I will do that for you real quickly. So when I simplify that, I get 6 over 2 and 10 over 2, which basically means 3, because 6 divided by 2 is 3, comma 5 would be the coordinates of W. The next thing they want to know is how long is each of the segments. So from B to C. Well, hopefully if you see it's going from 1, -2 to 8, -2, the only thing changing are the x values, and from 1 to 8 must be 7 units. So that's how long BC is. Hopefully you remember then that if it's a mid-segment, that's half, and half of 7 is 3.5. So that's what WH would be. And they want to know how else they're related, and the other way they're related is that they're actually parallel to each other. They are parallel, and one is half of the other. In question number 26, they want to know if this is a circle or a parabola. And so I notice, first of all, that they're both squared. If that's the case, then it's a circle. And in order to graph it, we need two things. We need the center, and we need the radius. The center in this case would be a +3, because it's the opposite, comma -1, and the square root of 9 is 3. So to graph it, I'm just going to go to the point 3, -1. That's my center. And then you just go 3 in each direction, and then you just kind of sketch your circle from there. So it looks something like that. In question number 27, they ask us to graph this equation, and we need to decide if it's a circle or parabola. And hopefully you've started to recognize the difference, and since only one is squared, this is a parabola. Okay, so we know it's going to be a U shape, and there are several things I need to know before I can graph it. First of all, I need to find the vertex. And it's always nice to find the focal point, or the focus, and I want to know if it's going up or down. And in our case, because it's a negative 16, we know that it's going down. The vertex is the opposite of the parentheses, so it's a positive 1, because it's the opposite of this one, comma, negative 2. And if 4p is equal to this number right here, negative 16, we know the p-value is negative 4. So I'll sketch that for you real quickly. So they asked us to find the vertex here. So 1, negative 2, so this is the vertex. I know that it's going down because of the negative 16. So it looks something like what you see there. And then the focal point, since p is 4, the focal point is 4 units away from the vertex. And the parabola always surrounds it. So 1, 2, 3. So the focal point would be right here. One other thing that your teachers have asked and discussed with you is something called the directrix. And the directrix is also 4 units away, but it's going in the opposite direction. So I'm counting up instead. So it's a line that looks like this. This is called the directrix. In question number 28, it's also the same as the one we just did. First of all, they asked if it's a circle or parabola, and hopefully you recognize only one is squared, so it's a parabola, so it's a U shape. And similar to the last question, the first thing I need to know is what's the vertex. I want to know the focus, and which is really our p-value, and I want to know if it's going up or down. And so when I look at this positive 12, positive is going up. So I know the parabola is going up. The vertex is at the opposite of that parenthesis, which is a negative 1. The opposite this, which is a negative 4. So negative 1, negative 4, our vertex is right about here. Now, because I know it's a positive 12 and going up, the parabola looks something like this. It could be a little wider, could be a little skinnier. When I'm looking at for the p-value for the focus, if 4p is equal to 12, because remember it's always 4p, that would mean p is 3. So that means 3 units away from this, going up 1, 2, 3, the focal point would be right here. And if you were asked for the coordinates of the focal point, that would be at negative 1, negative 1. Now the directrix is also 3 away, but it's in the opposite direction. So it's a line down here. And if they asked you for the equation of the line, the equation of that line is just y equals negative 7 because it crosses the y-axis at negative 7.